conference. So our next speaker is Leo, who is a developer at Deno, and he's going to talk about how to create a JavaScript runtime with Rust. Big round of applause for Leo.
Hello, I'm Leo, as I was just introduced. I work at Deno, and I do various Rust. Well, at Deno we do a lot of Rust, and we created a JavaScript runtime, but we want other people to be able to use it as well and make their own stuff with it. So we will a bit explain internals and how you can make a small JavaScript runtime by yourself. But first, what is Deno? Many people still don't know, so better explain. It's a JavaScript runtime similar to Node, maybe similar to Bun if you've heard of Bun, that focuses on security, web compatibility, TypeScript out-of-the-box support, and just a lot of built-in tools like a formatter, linter, doc generation. We also have compiling to a single executable, and a bunch of other tools. We are also not 100% fully Node compatible, but we're getting closer and closer by the day, and it's getting quite well. And what matters to this presentation is the modular code base. We have a lot of building blocks that can be used individually to build your own JavaScript runtime, just with these Rust crates or Rust libraries to make your own one, without too much effort, actually. We simplified this a lot. So first off, we need to explain the internal structure of Deno, which is, everything is built on Deno core. Deno core is a layer above V8, which is the JavaScript engine that powers also Chrome and all the Chromium browsers. And Deno core is just a small wrapper around it that simplifies a lot of the utilities around it and makes it a bit more friendly to use. It's not always easy to directly use V8 by itself. And on top of that, we have various other functionality that's built on top, and that's extensions. Extensions are individual libraries that can be used by themselves to implement functionality, individual APIs and functionality. For example, a specific web API, like let's say fetch, or FS operations are an individual extension. We have HTTP server, KV, bootloads. So basically everything is individual building blocks that can be not copy and paste, but imported and just used without too much hassle. Like usually to add an extension is like 3 lines of code, and then suddenly you have a massive amount of more APIs that you can just use. Then we have Deno runtime, which is a library that is built on top of a bunch of extensions that adds a bit more capability to it, including our permission system, which relates back to us being a secure runtime. We have various permission-based functionality and flags. And also another additional feature would be the fact that we do some definitions of various global scopes and the Deno namespace itself. And also web workers are only implemented in this Deno runtime crate because it's just not possible to have it as an extension, just because it needs to interrupt with the extensions themselves. And then we have the CLI, which is what we compile and what people use, and that's not great. And CLI includes the TypeScript support, a bunch of other, like all the tools of the CLI, like the linter, the formatter, etc. And also then, we have the compile subcommand, as I mentioned before, that lets you compile to a single executable, and testing infrastructure, benchmarking infrastructure, and doc generation. We have a fully static HTML doc generator that you can just use and will always give a relatively clean output. But what will we build today? Today, we will build a JavaScript runtime that can transpile TypeScript, has a functionality to make a HTTP request, a console.log, some file system operations like read and write, and deleting a file, I think, as well. And it's all in less than 30 lines of Rust and JavaScript. We will call it run.js, just because. This will be a relatively technical topic, so there's going to be a lot of code. So you won't. First, let's explain extensions more in depth. Extensions have various fields and options that can be set. Ops, which I will explain in a moment, basically declare Rust functions that can be used in JavaScript, so you can just write a Rust function and that will then be callable out of JavaScript. ESM is the ES modules, so you can use ES modules, import static imports, and dynamic inputs work as well, I believe. Maybe not. JavaScript files are just scripts, so not ESM to include. It all works differently under the hood, so we have these as two separate options. And then depth is declarations of other extensions. This extension depends on. This is not necessarily needed. It's more of a safety harness. Just it makes sure that you actually initiated the extensions in the right order, so you don't actually forget to initiate an extension that another extension relies on, and then everything implodes, and then you don't know what's happening. And there's some other relevant, less relevant options like config. JS, as I mentioned above, is rarely used nowadays. And then lazy loaded ESM state and more. I'm not going to go into depth. It's just config lets you configure some, add options to a specific extension. If you want to have some special state, you can use the state option. Lazy loaded ESM lets you lazy load extension code, but that's nothing that we're going to go into depth or even look at this in this talk. And then ops. So ops are these functions that you can declare in Rust that then are used in JavaScript. You can just call it like a normal function in JavaScript. And it uses this up to macro. I hope that's not too problematic of an explanation that what a macro is. I hope everyone knows here. It should not be a problem. And then basically you define arguments and return types with these special macro attributes like the string or this string. And basically it infers then the right type to map it from JavaScript to Rust, and vice versa, depending on the attributes. And yeah, you just write a normal Rust function, like for example in that, we just use Tokyo, which is, Tokyo is the async executor that we use in Deno, and most of the Rust ecosystem uses it, and then we just read the string, we read the content of a file, of the path specified, and we just return it. And we return everything in ops as a result, which is either an error or an acceptable value, because you might want to throw an error, for example, and that just handles it under the hood, or so you just return an error. There's other various types that can be specified in ops, where you have some more ambiguous types, like a V8 value, which is just a generic JavaScript value. You can pass that, and it can manually match and do some more specific handling if you need some weird function that does based on different types something, which usually we try to avoid, rather have separate functions that do more specific things. But then we also have Boolean are supported, numbers, strings as their array buffers are supported as well, and yeah, you can return and accept array buffers, and it all handles on the hood without issue. It's all been simplified as much as possible to make it as user-friendly or developer-friendly as possible, so it's really easy to just create your own functionality without too much difficulty. There is also this async is defined up top. It makes sure that the function is actually async and that it does need to use async functionality. When you define something as async and you don't do anything async, it will usually then error out during compile time. So because async, it's just more complication under the hood that makes it less performant to some degree. Then here comes the code. So for this example, we're going to define a few ops or Rust function declarations that can be called from JavaScript. And we have read file, write file, fetch, set timeout, and remove file. So in the read file, as we just saw, we read the file to us from the path given and return that. With write file, we specify a path and the content both as a string, and write that to the file, to disk, and we return nothing as per the empty type. And then the fetch one, which might be the most interesting out of all of these, is basically uses request, which is a Rust crate for doing HTTP requests at, I guess if we want to compare to something in the JavaScript ecosystem, would be similar to Axios, I think. It's relatively similar, maybe not similar in API, but similar in functionality and simplicity. And yeah, we basically just do a fetch request and get the content of the body via the text method, and then just return the content. And then we have a set timeout, which just puts the current thread to sleep, and for the specified duration that's passed by the user via this function. And remove file just, well, removes the file, at least given the path. However, we use a whole system called V8 snapshots, and it's gonna be part, I apologize because it's a very complex topic. Not many people really know what it is or even how it works. But to very simplify it, it's lets you take the current state of the JavaScript execution and you can store it in a file and resume it later. That's the simplest way to explain it. It's not exactly like that, but for simplicity's sake, let's stay to that. So we need a build script because we first need to do some setup. So first we initialize our extension. We call it run.js, as we said earlier. And we have this ESM entry point. I did not mention that earlier, but basically lets you specify the entry point that runtime will use when starting up. And we specify our files via this ESM option, and we have this JavaScript file, which we'll see just in a second. And we have some path defined. We want to get the path of the current build script location, some more specific Rust shenanigans, but we get this path and we join it with this run.js snapshot. It could be any path, just we need a common location where this build script outputs something that we can then retrieve during runtime. Now comes the fun part, which is this create snapshot utility function that we have made that does all the snapshotting logic under the hood, tries to simplify it as much as possible, and we have a few options. Most of them can be completely ignored. The only three important ones are the manifest there. We cannot infer this automatically, so we have users to always set this value to be this env macro call to the cargo manifest directory. The snapshot path is the variable we defined earlier for where the output of the snapshot will be, and then we have extensions, which is the extension we created earlier above, and we just want to initiate the JavaScript code. We don't have a just initiate ESM file, it's initiate ops and ESM. Here we have not defined ops, because this is just doing the build script. We do not care about ops at this point in time. They will come into play in a moment. First, we also want to support TypeScript. And this is just a small snippet of the code. There's some more boilerplate that is not necessarily interesting. It's just getting the path of the file and the media type of the current file, just to be sure that we actually transpile JavaScript and TypeScript to JavaScript and that the file types are all correct. But for that we use this Deno AST crate, which is basically a wrapper around SWC. SWC is a Rust crate, a library that basically implements type stripping as per TypeScript's wants and needs, since there's no real specification because TypeScript. But takes some options, the specifier, which is basically the path or the name of the file that we want to transpile, the source code, so the text info we just create this structure from the code that we got earlier from this read to string at the top, from the path that was specified by this function, and some boilerplate, this media type that I just talked about, and then we just call transpile, and magically we get the transpiled TypeScript as a JavaScript, and we can just use it. And then we have the code, and we just create a structure of module source, which is how it internally is represented, and we just return it. And this is all in trait. I guess the best way, if you're familiar with TypeScript, is like an interface and we implement this straight, and it has a few methods, but only one method is really necessary, and it is a load method, which is what this is in. There's a few more lines quoted above, but again, that's just for media type and some smaller error handling that is not really out of too much interest for this scenario, or for the simplicity. Then we have this is in the actual main script, where we get the snapshot that we created earlier during the build script and include it into the binary itself. And then we have access to this runtime snapshot, and we will use it later on. And then we have the extensions. We initiate again, but this time just with the ops that we defined earlier. And this time we don't need the ES modules because we defined them earlier and snapshotted them, so they're part of the runtime snapshot from above. And seems I forgot a slide. I can quickly, hopefully, fix it. This is not well prepared, my apologies. I hope this... Wait, let's do it the easy way. This is the JavaScript file with the internals defined, and basically we input Deno core as a JavaScript. There's a JavaScript module that you can import if you use Deno core that has some utility, some functionalities, again, just like the Rust version, just this is for interrupting between the Rust and the JavaScript. And we have destructured this core into ops. Ops, again, this is then an object that can be used to access the functions that we defined earlier, as we see over here, that I hope it's big enough, actually. Can the people in the back read it? Wonderful. Is this big enough? Wait, then let's... Okay. So yeah, just to quickly reiterate, we have this import of Deno core and it's structured into this ops object, which is just down below here used to call this op read file, which is the one we defined in the Rust file earlier. And all under the hood, it converts the values to the correct type matching in the Rust, and then whatever it's returned from this op read file, which will be a file content, we then just return it from this function that we defined in this object constant. Over here above, we also have the console definition, which is uses coda print, which is a utility defined in Deno core. Again, a few more helpful tools, and we just get all the arguments and just use this args to message that we can define above, which means just stringifies and joins all the values. We don't need anything too complex for this example, and then just prints it to the console. And then we have the same for error, which just sets at the end the true value, which is for okay, if it's an error or not. So above it's false, and then below it's true. Then further down we have the other function definitions, which are read file, write file, remove file, fetch. Maybe just all wrapper functions around these ops. Technically, this async is not needed. That's one oversight, but whatever. And then we have the set timeout, which calls the set timeout and then calls the callback. So it's relatively identical to the web API that we know. And it assigns this to global this, which is the global namespace, and also we assign to the global this also the console. And we define a run.js function object, which is the object we defined above with all these extra small functionalities. To go back to here, yeah, we defined this extension again and the runtime snapshot, and then we have basically all the building blocks ready. Now we just need to actually use it. And for that, we need the runtime. This is, again, a bit more complex, but basically we define a function that takes a file path. The file path is the JavaScript file we want to execute with the user's code that they pass. We have some utilities in Deno core that resolves the path against the current directory and gives you a module specifier out, because that's what internally it's needed to use. Then the module loader is what is used to resolve a module and any imports in it from this user-specified file. And we have a TS module loader. This is basically the TypeScript transpiler that we built earlier. That is just the structure that is defined, but I did not show that because it's a bit boilerplate. Startup snapshot is the snapshot that we got from earlier from the setup. And then the extension, we need to initiate the ops that are defined so that the Deno core and the JavaScript file that we designed can actually access these functions and load them up. And we don't care about any of the other options. And then we have the actual usage, which is this load main module. The load main module, it loads the main module of the entry point. Let's say if you run Deno run test.ts, that would be the main module, and then it walks through the entire module graph, which is basically all the imports one by one on the recursively. And this is async. A lot of this operation is async because ES modules are inherently async. And we evaluate the module, so we basically run it and get if there was any output, and then we want to run the event loop because there's going to be multiple pulls. Let's say with async functions, you're going to do multiple async calls perhaps, or just stuff. We have some options that are not of interest. We have Deno core includes inspector, utilities, and pump v8 message loop, which is again not much interest. It's some monitor, and then we just await this event loop running and return value of this result that we were calling earlier. So we just then get out of this run.js function, we get the result, which hopefully will be okay, and there's not going to be any errors, but there might always be some error. User might have to find incorrect variable names or have invalid syntax or something like that. And then we can do a small demo where I hope it's going to then be big enough again. That's definitely not. We have this example.ts file. Here we just call the set timeout that we defined earlier in the global scope, and then just timeout, and this can then just be, can I make this bigger? No. So just live demos never go perfectly well, but hopefully this should be working. So we then just do cargo run, and we want to specify this input file, which we called example.ts, and hopefully this will work. It first needs to compile, and yep, it prints the wait and then the hello world that we call here. Now this is just a set timeout. That's not as interesting as, for example, fetch. So I mean, we could just console log the fetch output, so it would be run.js because we defined this global variable earlier as run.js in this runtime.js down here, and then we want to call fetch, and we could fetch http example.com, and since this is async, we want to await it, and again let's run this, and hopefully we'll get an unreadable wall of text of HTML output from example.com. Usually it's not that long, and yes, we did a fetch request to a remote server. Then we had the file system operations, so I could just call await run.js dot read file, and let's read, for example, this file itself. And then let me clear my terminal quickly. And hopefully it should just print the same output because we're reading self file. Yep. And it reads, and then the deleting and writing of files will work as well. I'm not going to go too depth into that. It's relatively self-explanatory. And yeah, that's pretty much it. I know I went a bit fast. I hope people don't have questions. There's a QR code for the actual repository where we have this, so if people are interested to check it out. But also that, we always are trying to improve the ecosystem and common problems of the JavaScript ecosystem. And we actually have had problems with the dependency ecosystem of JavaScript and NPM, and we decided that someone needs to solve this. And as such, we also creating a new general purpose JavaScript registry that will work in any runtime. This has been announced a few days ago by Ryan more in depth, and you can join the waitlist at the QR code or the URL. That's it.
Are there any questions? We have time for one or two questions. Yeah.
Let's say that I made this inside Docker container. I have this listening to a queue of jobs where I send just the script that I want to run, and then just execute it and the outputs from it. Is there any downside as long as I am only sending one single script that it needs to execute?
No, I don't see any issue with that whatsoever. It should just work. Again, I'm not too familiar with Docker though, but that seems like a relatively normal thing to do. Any other questions?
What have been your biggest challenges into writing this Rust project?
Ooh, that's a good question. I mean, this project has been going on since it was announced in 2018, and we have rewritten our internals many times. For example, extensions were called other things multiple times in the past. We renamed and restructured not the entire structure of the code base, but it was just multiple rewrites just to be able to have more capability, but also performance-wise improvements. But overall, it has been a challenge, but it was something we could always figure out. Rust itself has never been an issue. It's always been relatively good to use. I mean, it's not perfect. No programming language is perfect, but previously Deno was initially started as a Go project, but we switched quickly to Rust for performance benefits as well. And yeah, I hope that answers the question. Anything else? Yeah?
One of your slides, you were building operations.
Yes?
And for one function accepts float, but then you can't do what's the set time out. I'm wondering why do you have
Is it on this one?
yeah, set them out. Delay, load, but then you can't accept.
Okay, yeah, this could technically have been just accepting U64 directly. This. Oh. Yeah. Like this should actually have been U64 directly and just been passed and not casted. But that was probably just some oversight while writing this code. But we cast it because this from Melissa obviously accept only U64. But yeah, this just oversight.
I have one more question.
Yes.
How does the performance on the custom runtimes or extensions compare to the foreign function interface also present in
Oof. I'm not too familiar with FFI, but I mean, we have optimized both FFI and these extensions a lot more, but extensions inherently are going to be more performance because it's not foreign function. These ops are I guess if you rather really look at them, foreign functions, since it's calling Rust functions out of JavaScript, there is some plumbing, but these have been optimized so much over multiple years that I would say like sing functions are basically maybe not no cost, but close to no cost. Async functions have overhead due to